Imagine this. You worked tirelessly on a lesson plan, created a digital assignment that your mentor can't hate, an irrelevant assessment, and executed it perfectly, only for the kids to say, "You didn't teach us that," or worse, have no idea what you're saying. Congratulations. You just taught French in German, and it was a math class. There is a debate that is raging right now that says it's all technology's fault, or that traditional is too stuck in the past to be relevant in this current connected world. But that's a false debate. The better question is, how can educators intentionally combine paper and screen to improve learning, rather than which one is better? So what would that look like? This. Hybrid artifact-based learning, a technology-integrated instructional method designed to support retention and metacognitive awareness, is a better choice because it leverages the unique benefits of physical text, handwritten learning artifacts, and digital assessments, integrating them into a unified instructional model. The HABL learning cycle. The HABL framework conceptualizes learning as a cyclical process rather than a linear sequence of instruction and assessment. HABL proposes 4 cognitive mechanisms: encoding, externalization, iteration, and reflection, which interact to produce retention, transfer, and metacognitive awareness. To deliver these benefits to students, the learning cycle is split into 5 phases: physical input, physical encoding, digital artifact development, digital assessment, and metacognition. The traditional aspect. Research on learning and memory suggests that students retain information more effectively when they process it themselves. They must organize, retrieve, and apply what they learn in a visceral and practical manner. Craig and Lockhart, in their work Levels of Processing, a framework for memory research, wrote that retention depended on aspects of study time, the amount of material presented, and the modality of assessment, as well as the familiarity, compatibility, and meaningfulness of the material. They also state that retention is a function of depth. Information that is processed deeply through meaningful engagement, organization, rehearsal, and elaboration is more likely to be retained than information processed on or at a surface level. This justifies the first 2 phases of the learning cycle. Phase 1, physical input, is where students interact with information through physical texts, manuals, articles, blueprints, scripts, and case studies in order to provide rich informational input and support focused engagement with content. Phase 2, physical encoding, is when students create their handwritten physical artifacts, such as Cornell or 3R notes, annotations, journals, concept maps, sketches, and graphic organizers to support knowledge construction and supercharge memory encoding. According to Fiorella and Mayer in their book, Learning as a Generative Activity, 8 learning strategies that promote understanding. Students learn more deeply when they generate meaning through activities such as summarizing, mapping, drawing, explaining, and note-making. They must make sense of the material that is given to them. This is accomplished through 3 cognitive processes: selecting, organizing, and integrating. Generative learning theory helps explain the function and benefit of the traditional approach that a hybrid artifacts-based approach addresses. It works because it works. The technology aspect. Kohler, Mishra, Akalu, and Rosenberg, in the Technological Pedagogical Content Knowledge Framework for Teachers and Teacher Educators, state that the TPAC framework describes the kinds of knowledge that teachers need to teach with technology. They go on to say that teaching is a context-bound activity and that teachers with developed TPAC use technology to design learning experiences tailored to specific pedagogies, content, and learning contexts. We see this in the next 2 phases. Phase 3, digital artifact development, where students actually transform learning into digital artifacts like e-portfolios, videos, business plans, and multimedia projects that support revision, collaboration, and application. And Phase 4, digital assessment and feedback, where students receive performance data through online assessments, rubrics, analytics dashboards, peer and instructor feedback. The final phase is Phase 5, metacognitive reflection. Teaser in Cognition and Metacognition in Education, which was written in 2024, defines metacognition as skills of being aware of one's own learning and memory capacity, knowing the qualities of the learning strategy to be used, planning for the study to be done, using effective learning strategies, and monitoring and evaluating the learning situation. This is when students examine what they learned, how they learned, which strategies were effective, and what should be improved so that they can develop learning awareness and self-regulation. All the artifacts become reflective tools that help kids monitor their own learning. This is extremely important because this is the final step to creating meaningful connections to teaching, learning, and creation. What HABL is not. It is important to realize that the HABL framework is not one-to-one computing, blended learning, paperless classrooms, or technology for technology's sake, but rather technology intentionally selected for its contribution to learning and physical processes and traditional teaching methods selected for their ability to help students remember, recall, and retain what they learn. Applications across disciplines. Let's look at some specific examples across classrooms to see how this framework would work in practice. CTE. In a, let's say, welding class, the progression would look like blueprint to weld journal to weld product to digital portfolio to reflection. The kids would look at the instructions, write down what you're doing or what they are going to do. Then they would build their project and upload pictures of the process and the result to an e-portfolio. Then it would be there to reflect on and think about what they learned, analyzing their welds and how closely they stuck to the plan, and they can do even better next time. In a business classroom, students could read about a business problem, write down their ideas, and then create a solution and a business plan to support it using Microsoft Office tools. This supports skills needed to pass certification tests for the class. After that, they would present it using technology in a mock pitch meeting and see how people responded. Finally, they would reflect on what they learned and about what worked and what didn't. In an AV classroom where HABL was born, you would write your message or script, plan your video, create it, check how it performed, and think about how to improve it. The key to success here is to use production notebooks and annotated storyboards throughout the distribution phase of the project. These are powerful tools that encode information much more deeply than digital projects do. English language arts. In a language arts class, it would look like read the text, then take the notes, then write your analysis in the form of a recap episode of a reality show. Then use digital tools like Notebook LM to create a podcast about the episode and share. Then reflect. Math. In a math classroom, it may be learn a new concept, then work out the problems by hand, then solve a real-world problem and use Canva AI, Adobe Firefly, or Comic AI to create a comic book where the hero uses this solution to beat the bad guy. Aura farming using math. Who knew? Then present your work online with a WordPress site. Reflect. The impact is clear. Using the HABL framework means designing lessons that create artifacts, ethical, personal, and fun ones, that are made in ways people learn and remember, not just for the sake of using technology. Any classroom can become a place where encoding, externalization, iteration, and reflection become more than just edu-speak, but actual products that the kids would be proud of and fully engaged in creating. At that point, retention, transfer, and metacognitive awareness are just what you do, and not just what you want.